Hi, welcome to this week's lesson. The lesson topic is erosion by water, and we are still studying Unit 5, Earth's Systems. Both assignments for this lesson are due by next Monday, May 11th at 5 p.m., although you may turn them in sooner. Again, our schedule. Wednesdays, we have Zoom meetings, 6:11 and 6:12. Your meeting is from 11 to 11:45. 6:13 and 6:14, your lesson is from 12:30 to 1:15. And my virtual office hours are still on Tuesdays and Thursdays. I've provided the links here for you to access these Zoom lessons, as well as my virtual office hours, so that you don't have to search for them anywhere else. This slide is for our Zoom meeting on Wednesday. You'll follow these steps when you come into the Zoom meeting. I made the Pear Deck lesson a student pace lesson for this week so that you won't feel that we're moving the lesson along too quickly. I've uploaded assignments 008 and 009 into Google Classroom, so I'm going to have you open those while we're in our Zoom meeting. And I'm also going to have you log into Clever and go to Discovery Education Science Textbook to find your assignments for the week. We're going to do a stress check during our Zoom meeting. We're going to give a thank you to someone in our class. And then we're going to get right into the lesson, Erosion by Water. The objective of this week's lesson is to identify and explain soil erosion caused by water. So the big idea here is that moving water, whether it's liquid, whether it's frozen, it causes soil erosion, which can affect the shape of a landform. We're going to watch this Engage video, The Power of Water for Kids, How Erosion by Water Shapes Landforms. When you click on it, it's going to take you to safeshare.tv. The reason that I have this link embedded here is to protect you from having to watch ads and commercials.
The Earth is covered in many different landforms. Landforms are natural features of the Earth's surface, like mountains, deserts, and plains. Although they may seem permanent, they are constantly changing, and much of that change is caused by a surprising force: water. Water changes the land through erosion. Erosion occurs when the surface of the earth wears away. Water can break down rock and dirt and carry the particles away to another place. This changes the shape of the landscape. The ocean is a powerful cause of erosion. Waves beat upon the shoreline, breaking up rocks along the coast. Sometimes this forms cliffs. Other times it may form beaches. Still other times it can create rock formations sticking up out of the water, called sea stacks. The way the ocean erodes the shore depends on how the water moves and what kind of rock the shore is made of. Rivers can make big changes in the land too, and the Grand Canyon is a famous example of this. Over many years, the Colorado River has carried away particles of dirt and rock, carving its path deeper and deeper into the ground. Today, the Grand Canyon is over 6,000 feet or 1,800 meters deep, and 18 miles or 29 kilometers wide in some places. Water does not have to be liquid to cause erosion. Ice can do it too. Glaciers are sometimes called rivers of ice because they are huge slabs of ice and snow that move very slowly across the landscape. As glaciers move, they break off and scrape away pieces of rock and stone. Glaciers can create many different landforms, including deep valleys, lakes, and fjords, as they carve their way across the land. Although water is not the only force that changes the landscape of our planet, it is an important one. Whether it's a whole ocean or just some rain, a little water can make a big difference. I hope you enjoyed learning about erosion caused by water today. Goodbye till next time.
I hope that you enjoyed that video. If you want to take short notes in your science notebook, you can do so at this time. However, it is not required. So during our Pear Deck lesson or on your own, you can summarize what you've just learned from the erosion by water video. Then we are going to start a mind map by typing or drawing anywhere. And the central topic is going to be causes of water erosion. So you can type answers here, 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 or anywhere in the white space. Explore. This is optional. If you want to create your own erosion, watch this video and try it at home with the help of an adult. So I'll play this video on how to create your own erosion. Again, it's a safeshare.tv link to prevent ads.
Have you ever seen the Grand Canyon in Arizona? Or the White Cliffs of Dover? Or maybe you've been to the beach recently. These landscapes are all beautiful, but how did they form? Well, they formed when the materials that make up the land were moved from one place to another. This movement is called erosion, and you can see erosion in action for yourself right at home. We're going to create our own mini landscape to see how water can cause erosion to change our landscape into something different. Before we gather our supplies, we're going to make sure we're in a place that's okay to make a mess. Okay, we'll need a deep pan or a tub. We'll also need a plastic or paper cup and some scissors so we can poke a hole in it, and some water. And finally, we need something to make our mini landscape with. You can use sand or potting soil or anything that's made of little pieces that can move from one place to another. Now that we've gathered all of our supplies, let's make a landscape. First, let's fill our pan about halfway full with dirt. And this is where things get really fun. It's time to get messy. All right, let's make sure our landscape has a slope, kind of like a little hill, so that the pan has more dirt on one end than the other. This slope will allow our water to move from place to place, so we can see erosion in action. Next, let's add some little features to our landscape, just for fun. Maybe a couple of mountains over here, and maybe a cliff over here. Once our landscape is finished, let's take our cup and poke a hole in the bottom. Very careful. You might want to ask a grown-up for help with this part. Next, hold the cup of water over the side of the pan that has the most dirt or sand. That's the top of our slope. Now, let's pour the water in. And look, the water is dripping down through the hole and moving down across our landscape. As it moves, you can see that the water is taking some of the dirt with it, moving it from the top of the slope to the bottom. So how do we know that we created erosion? Well, does your landscape look different than it did before? Is there more dirt at the bottom than there was when you started? How about at the top? Is there more or less dirt here than before? And what about in between? Can you see where the water traveled from the top of the slope to the bottom? Finally, take a close look at the water. What color was it when we put it into the cup? That's right, it was clear. But what color is it now that it's run down the slope? Right again, it's turned a mucky brown color. That's because as the water was trickling over the dirt, it picked up tiny pieces of it and moved them along. If you've ever seen a muddy brown river, that's how the river got that way. As the river runs down a slope, it picks up bits of the dirt and rock that it flows over, and it moves them along. Now, what if we did this again, but tried it a little differently? Do you think you could change how your landscape erodes? If you created different features in the dirt, Would that change how much the dirt moves? What if you made the slope of your hill steeper? And what if you dumped all of your water out at once instead of letting it trickle through that little hole? Keep experimenting and asking questions and let us know what you discover. And thank you for joining us on this fun, messy experiment. And we'd like to give a big thank you to Google Making Science for helping us make this episode. If you have a project you want to share or you have a question for me, grab a grown-up and leave a comment down below or send us an email to kids@thescishow.com. We'll see you next time.
All right, and let's remember, this is purely optional. Some people asked for some more experiments during our distance learning time. This is a perfect experiment for you to share with your family. I'd love to see pictures. You can email them to me at ramona.hutchins@pgcps.org if you choose to do this project. For the explain portion of our lesson, I want you to open Clever. You'll go to Discovery Education Science Textbook, and I've assigned a board of videos to you in the DE Science Textbook. You'll use these videos that are here in order to answer the questions that are on assignment number 008. In the assignment, I tell you which media and the title of that media you're going to be using from the board here. And I have the question here for you, and you'll type your answer in. If your answer comes up blue and underlined, no worries. That's the way that I've set your document up so that I can differentiate between the questions and your answers. Be sure to use complete sentences. These videos will go into excellent explanations about how water erodes the land in order to create new landforms and change existing landforms. Then we'll do the elaborate part of the lesson, where you will watch this coastal restoration video below and answer the question after you view the video. The question is going to be, what is the purpose of building a small-scale model of a portion of the Mississippi River, and how can it help restore the delta? Let's watch that video. This video will take you into Discovery Education Science Textbook, and then you'll just click play and watch the video. You can make it large.
Each day brings more stress to the marsh that has protected and nourished this area. Why is it deteriorating so quickly? By studying the Mississippi Delta's natural land building process, scientists and engineers can identify effective ways to reconnect the river and the bayou without damaging livelihoods and industry. Working with the only existing small-scale model of its kind, researchers at Louisiana State University have found a way to study the effects of freshwater and sediment diversions for coastal restoration.
Well, the objectives of this model were to look at the feasibility of different sediment flow or river flow and sediment transport diversions in the lower Mississippi River.
Louisiana State University professor of civil and environmental engineering, Dr. Clint Wilson, and his colleagues are using this 675 square foot physical model of the lower 76 miles of the Mississippi River to determine where water and sediment diversions will have the best impact.
This material represents the coarse grain sizes of sands that are suspended in the Mississippi River flow. It represents about 30% of the total sediment load. The rest of it is made up primarily of silts and clays.
The sediment in this experiment refers to particles of dirt that are carried by the velocity of the river and deposited when the water slows down. This helps build land.
This is a diversion site. The gravel represents the roughness that's created by the tall marsh grass, which simulates the sediment process.
Diversions are thought to be a natural solution to rebuilding Louisiana's wetlands. A diversion is made by creating a hole in a levee, so a controlled breach of water-laden sediment is allowed to flow from the Mississippi back into the freshwater-starved bayous.
And as the sediment moves down to the location of the diversions, you will see sediment coming out of the river and going out into the marsh. However, by knowing where the sand goes, and also coloring the water with dye, we can anticipate where the clays and sediments will go as well. The area of the deposition will grow with time, and that simulates the natural growth of the sediment of sands going out into the marsh.
Built in France and housed in its own building on the LSU campus, the model gives researchers the ability to make changes to the river and then see their long-term effects.
We can do studies over long periods of time at a relatively inexpensive cost and in a relatively short amount of time. For example, we can run a 100-year scenario in 50 hours of model time. In 1 hour, we can run 2 years of Mississippi River time.
By placing diversions at various points along the model, Dr. Wilson and his team hope to determine the most favorable spot to build the next structure. These recommendations affect many lives and millions of dollars of infrastructure, possibly saving the area from destruction by future storms.
Using a small-scale model like this has only been used a few times, perhaps once in France and once in Canada. And now we've brought this technology to the United States to solve what we think is a very important problem, and that is to preserve Southeast Louisiana.
So now, after viewing this video, you will answer the question, what is the purpose of building a small-scale model of a portion of the Mississippi River, and how can it help to restore the delta? Pause the video and answer this question at this time. For the Evaluate portion of our lesson, you'll log into Clever, then go to Discovery Education Science Textbook to access your Erosion by Water assessment. This is assignment number 009 in Discovery Education Textbook. And it's also listed as assignment number 009 in Google Classroom. After you take the assessment in DE Science Textbook, you'll go over to Google Classroom and click Submit. That will then signal to me that you've completed the test, and I'll be able to pull your score. The score that you make on this assessment will be the score that goes into SchoolMax. After you take the assessment, just click on Submit in Google Classroom. Your exit ticket during our Zoom meeting will be to draw or type 2 things that you learned in today's lesson. Let's recap over this lesson. The first thing that we did was the stress check and gratitude activities. Then we did an engaged video. We watched an engaged video together on erosion by water. We did 2 checking for understanding activities, a summarizing activity based on the erosion by water video, and then we did a concept map activity. We then moved on to an explore activity that was optional, where you could create your own erosion. Then we did the explain portion of the lesson. That's assignment number 008, where you have this board of videos and images in Discovery Education Science Textbook, as well as a Google document that is posted in Google Classroom, where you will answer questions based on those videos. Then we did the elaborate portion of the lesson. That was based on a DE Science Textbook video and question. Next, we did the evaluate portion of the lesson, which is an erosion by water assessment that's found in DE Science Textbook as well. When you complete this assessment, you'll go over to Google Classroom and click Submit. This will count as assignment number 009. Finally, in the lesson, we completed an exit ticket where you drew or you typed 2 things that you learned about erosion by water. Finally, I'd like to leave you with the links once again to our Wednesday Zoom meetings and our office hours. This week's Zoom meeting will be a little bit longer. It'll be about 45 minutes because we have a lot to learn about erosion by water. I hope that you enjoyed this lesson, and I look forward to seeing you all on Wednesday. Have a good day.